The final section of Chapter 1, Introduction to Python, covers variable scoping, and this is Section 6 of that chapter. And we start off with the concept of a namespace. A namespace is a dictionary of variable names and their values. So let's talk about the three levels of namespace, which will define the scoping rules for variables. There are three. The first is what we call the local namespace. It's created when a function is called, parameters are passed, and variables are created within the function. So when you create a function, those parameters and any variables that you create inside that function, we would say is part of the local namespace. Those variables and the associated memory, it's deleted when the function terminates, and variables created inside the functions only have that function's local namespace. So anything you've declared or used inside that function is not available to any other function, just the function itself. Then there's the global namespace. That's created when an entire module is loaded with many functions, and the variables assigned in this namespace are visible to all the functions in the module. And the third is what we would call built-in. Built-in immediately when you run the Python interpreter. So I have a little diagram here at the bottom of this slide that sort of illustrates what we're talking about, that eventually the built-in namespace provided with the interpreter encompasses the other two namespaces. Global, which is the global namespace, which is variables that are available to all the functions, and then finally in the center, the local space there is just the variables that you've created for particular functions that you've defined, and they're only available inside those functions and not in the global namespace. So it's pretty consistent with you think about where things are defined and when they're available. And again, the built-in is created when the Python interpreter starts, and those variables are assigned. When they're assigned, they're visible to all the program units. So when the interpreter has to resolve a variable, it will start from the inside and then go back out. It will look to see in the current function, is it defined and available? And then it will check if it cannot find it in the local namespace, it will go to the global namespace to see if it's been defined globally for all the functions. And then if it's not there, it'll look in the built-in namespace provided to the interpreters when the interpreter initialized and started. And if it cannot find there, then it will issue an exception, and that exception is usually called a name error. You're trying to access a variable that's just simply not available for the interpreter. So here's some examples of variables created in the global namespace. Do not have to be passed to functions as arguments. Remember, even when we were teaching you in the intro courses in C++, how it's not a very good idea to use global variables. The same thing applies across scripting languages like Python, but you do want to understand what the meaning of the global namespace is in terms of it defining variables that are available to the functions. And I've got an example here that sort of illustrates that. So let's have two functions here. One is called divide1, and the other is called divide2. And notice that in the case of divide1, we have declared we have a variable c which will be dividing a by b, and that's making the assumption that a and b are available in the global namespace for this function because clearly they're not in the parameter list, right? So you see no a and b in this parameter list because there are no parameters passed to this function. So a and b must be in the global namespace. And then there's just a print that the string a/b equals and then a result. And divide2 is basically the same as divide1, except I'm not going to do the print there. Again, c is local to the function, but a and b are not. Very similar to divide1. So let's go down to executing some code inside the interpreter. Let's look at the first part. If you defined A to be a float of 100 and B to be another float of 5, and then called divide, then A and B would be in the global namespace for the divide1 function to use. And so when divide1 goes to execute this line C equals AB, the interpreter looks to see, well, A and B are not available in the function, so I'm going outside the global namespace, and it's going to find the nearest occurrence of A and B that it can use from that function called divide, before the function called divide1, and it sees that A is 100 and B is 5. It does the division and prints. So you get this result here. Again, I used an underscore here to indicate the space. Now, if we continue on and called the function divide2, all right, then again we realize that we're going to compute the division of A divided by B, and in this particular case, the execution is done. In other words, A and B are available in the global namespace for divide2, and so it actually does this computation, C equals AB, no problem. And so you know what the result would be. C would be storing C would be storing 20, just like it did in divide1. But C is not returned. There's no if there is no return statement, nothing is returned in this function. If I wanted C to be returned, I would actually need to, have a return statement in here and tell it that I wanted to return C. Okay, but it's kind of a messy return, but you get the idea. So when the print is executed after the call, so when divide2 is finished, what is in the local namespace is removed. It's gone. So C is no longer there. And then when the print tries to execute, it will throw an exception because C is not defined. Okay. So you have to be careful with the namespaces, but again, if you just think of the nesting of the local inside the global inside the built-in, you'll be fine. Now, just some other helpful hints and things that we've already covered, but just to review, for script files, it's a good idea that when you're writing Python code and you're putting it in a file, to name the file something .py. That's a natural extension for Python scripts. And again, if you would put the path to your interpreter after the pound exclamation mark on the first line of your file, then you can simply type the name of the file and it will execute the code. Alternatively, if you don't do that, you can execute your script by just indicating the name of the interpreter in your installation, mostly Python or Python 3.3 or whatever it's going to be called on your machine, and it will run the code. So again, you can put the commands in a file and execute it from a Linux prompt, a Unix prompt, by just saying Python and the name of the file, or you can just put the whole path to the interpreter as the first line and then just type the name of your program at the Unix prompt. Now, when you're running a program, the bytecode of a module is written to a file. In other words, the interpreter will make an interpretation of the code and generate bytecode for it, similar to like the way Java will generate bytecode. And that file that's created is called a .pvc file. And the interpreter always will be looking for a module's .pvc file first. So when you're executing your script files, you might notice some of these files being created. And the interpreter is efficient in the sense that if a function has already been interpreted and a .pvc file for it is there, it will use it. It won't have to do the reinterpretation. Now, one thing that might be very helpful to do, especially on Windows-based machines, is it's sometimes a good idea to add the input with, say, a prompt like press return at the very end of your code, because sometimes, especially we've noticed it on Windows-based machines, when it executes the script, it executes the code, and then the window that it was running just terminates and goes away, and you don't see any of the file execution anymore. So sometimes it might be a good idea to have it wait until you hit return or anything after a command prompt before it closes the program window. Again, it may not be a problem on your system, but if you notice that after you run it, the window goes away, here's one way of stopping that, or at least holding it off for a while. Now, one thing when debugging Python scripts you have to be careful about, sometimes the target where the interpreter is telling you to look for where the error is can be a little tricky. This is an example where we've imported the array function from NumPy and we've made an attempt to pass a list to the array function, but I think if you look very, very, very carefully, you will see that we are missing the right paren here. So it is not there. So just a question mark, where is it? So the rest of the code is fine. We would hope to print the array, and then again, here's an illustration of maybe, with input, and technically speaking, that should probably be a lowercase I there, but an input, press return. And if you executed this, it would generate an error. It would tell you if the name of this program was testmodule.py, it would say the error is in line 3. And it says syntax error, invalid syntax. And it looks like it's pointing to the print. So the problem is that it kept looking for a right paren to match the first left one and encountered another left paren. In other words, it encountered another left paren before it closed the other one, and that's what's happening. So it points to line 3, but sometimes if you'll just go up a little bit higher than that, in this case line 2, you would see, I left off a parenthesis. So you can't take some of these syntax error messages from the interpreter literally. You may have to go up a line or two to see where the error really is. So you have to be a little careful. Another good practice sometimes, and this is true probably for larger Python programs than the ones that we'll be doing initially in this class, but it's still a very nice practice, is that you can add what's called a doc string to the beginning of your module. In other words, you're creating a function in a particular file, and you might lead off with some comments. And here's an example of I'm creating a module called my_error. The doc string is just it's like comments that you could immediately get easy access to if you needed to print out the documentation for a particular function. The syntax is you start off with 3 single quotes and end with 3 single quotes, and everything inside that is called the document string. And literally whatever is in between those 3 sets of single quotes is what would be available to print if you could print the doc string of a function. So this is an example file here where you've got the doc string and then the function itself. You import the systems library, define my function called myError, takes a string, we print the string, we prompt the user to press return to exit, and then we exit altogether using the exit function provided in the systems library. So how do you print the doc string? Well, if I was to import my error, in other words, I'm telling the interpreter to use my function myError, which is available in, say, a file called my_error.py, then I could print the doc string using this syntax here, myError dot, and then you have _doc_. And then what was between those 2 sets of 3 single quotes would actually be printed on the screen. So that's an illustration of how you could print the doc string for any function to get it. It might be helpful to see sort of the preamble that someone's created for a function, just to see if you've used the parameters correctly. So it's a nice little feature for documentation. Last thing I want to go over a little bit is file I/O, because you'll want to be able to read data not just from the user but from files. It's fairly simple in Python. You use the open function, which is provided to you with the interpreter. You simply pass the string, which could be the path if it's not in the current working directory. In this example, we would be assuming that this text file sunspots.txt is in the current working directory. If not, you need to have the whole path to it. And then there's a lot of options you can specify on what you're trying to do with the function. Excuse me, what you're trying to do with the file. Are you trying to read it? So the second parameter should be just a character R. Are you trying to write it or create it if need be? Are you trying to append to an existing file? R plus means you're reading or writing to an existing file. Same, and W plus is the same, but you create the file if it isn't already created. And A plus would be the same thing as W plus, but it's using appending instead of writing and creating on top of it. So for example, if you looked on page 14 of the textbook, there's looking at some data related to sunspots, and this is just an illustration of trying to pull off some of the data. There was intensity data from the year/month/date/intensity columns. So this is just an illustration that if you had column-based data, and let's say, again, there were 4 columns. The first one was year, the second one was month, the third one was date, and the last was intensity. Here's an illustration of how you could create a list just of those intensities. We could start off with just an empty list indicated here with X just equals to 2 open brackets. Open the file, which has that 4 columns of data, and then use the for loop to iterate over each record in the file. So you can specify any variable you want here, but it's basically going to reflect every line or every record in the file. And what we can do then is use the append function for a list to build up the element of this list of intensities by evaluating, first of all, what the split function would do. The split function basically is just going to pull off, it's going to split, by default I think it's blanks, every component of the line separated by blanks, and there's options for split if you wanted to split on tabs or split on some special character. And this just says I'm going to pull off the 4th thing after you split it. If it was the first one, you'd put a 0 there. In this case, we want the last column, so it'll be in position 3. So eval will execute the split in terms of extracting that particular item, and that will be passed to append. And that's a simple way to use a for loop to go into a file where there are, again, 4 columns of data, and we're trying to pick off all the data in the 4th column. Okay. Very, very nice little example to show you how you could read data from a file, in this case, store everything in that 4th column in one particular array, X, and then close that file since we would have finished reading every single line and pulled off the component in the 4th column. Now on Blackboard, under the Lecture Notes Videos menu item, you will notice that I've posted sort of a Python set of files for a Python tutorial. It's basically just some Python script files which cover many of the examples that I've used throughout this Intro to Python set of lectures. And what you're seeing on the screen right here are different, there are 4 different basics files, basics 1, 2, 3, and 4, along with that example my_error.py that I did. So the zip file I created is called python_basics.zip. That is now on Blackboard, and you will want to go to Blackboard and download this particular file there, basics, python_basics.zip. and unzip it, and then you'll have these 4 files. If we looked very closely at basics.1, just to show you, this is what it looks like. You'll remember some of these examples in the at the very beginning when we were covering Python. Again, this file, I can execute it, and I will execute it for you in just a second. But again, pound, and then exclamation, and there's the path on this particular Mac Air that I have. That's the location to the Python 3.3 interpreter that I'm using. And just comments of the different examples we did, from looking at strings to what tuples are, and going through, immutability and talking about lists and so forth. So this is just a file that has all those commands on it, and I can simply just execute it at this command prompt. Again, this is running Mac OS X, which is basically a Linux type kernel, and I can execute it, and there's all the outputs of the print that would go to the screen. And again, I have provided all of those scripts for you, and you should take them, test them, play with them, modify them to see what the changes might be to the inputs and the outputs as you go through that. So, so I encourage you to run every one of those basics.py files to make sure you understand all the commands and the syntax related to the Python examples we've done. Again, that is on Blackboard now, and it's available for downloading.